Hi friends, so here today we'll be learning how to check or the logic to prove a number is irrational. So what's the meaning of irrational number here is, suppose you have got a number with you, say 3. We know that it's in simple form, right? It is already in the form of p by q. So we can say this number over here is a rational number. So rational numbers are the numbers which can be written in the form of p by q. So what is the meaning of irrational number then? So number which cannot be written in p by q form. That's pretty much an inaccurate statement. To understand the concept of irrational numbers, you have to think of some way of figuring out the definition of it. Okay, we'll take an example of square root of 3. A square root of 3 is technically a number if you find out the value of it with long division method or with calculator if you can. Then you will see that root 3 value will come out something of 1.72. And along with that, you can see some other values of the numbers also. It's root 2, root 3. But these values, what your computer or calculator gives, is not completely correct because the computer is rounding it off and giving the value to you. Okay? In the case of, you can see over here, root 2 is written 1.4142. But if you find a value of root 2 precisely with the long division method, it will go on forever. So characteristics of irrational number technically is the numbers which are never or non-terminating. It will not stop at all. It will keep on going on forever and non-recurring. So if you remember in ninth standard, you had numbers which were in recurring form and we wrote it in the form of P by Q. So if it is in P by Q form, it's a rational number. But if it's not, if it's you're not able to write it down and it's also non-terminating, it's technically an irrational number. So these numbers will never ever end. So the actual value of root 2 could be 1.414234779111 13, 17. It goes on and on and on. Does not have any pattern. It is not recurring form. It's something which you will have to, uh, it's someone no one can figure out. It goes on for infinite. Just as another example you can think of is pi. So pi, you might all think of it as the value of is 3.14, right? It's not 3.14. We are approximating it to this way, or the actual value of it, it goes on endless because it is an irrational number. So all the irrational numbers will be non-terminating, will be non-recurring. And one thing you remember, the value of pi, sometimes you write it as 22 by 7. That is approximated to pi. It's not equal to pi. Approximated is written as, I know, now this symbol that it says that pi is approximated to 22 by 7. You do not say pi is equal to 20 by 7 because 22 by 7 is technically a rational number. No, it's in p by q form, right? But pi itself is an irrational number. So that's why we are approximating the value of pi as 22 by 7, but in actual form, it is a irrational number. It cannot be written in the form of p by q. So how do we show if a given number is irrational number? We have two different ways of doing it. One, we can do it by finding the square root value of it, or sometimes cube root value of it, but cube root is something beyond. It need not be restricted to square roots itself. It could be cube root of 5. Even this happens to be an irrational number, or fourth root of 3, or seventh root of 10. These are all examples of irrational numbers. They are not going to be rational or irrational because the decimal form of it, if you find out it in your computer, you will get non-terminating answers, non-recurring answers. That's why this number are irrational. The one way of it is doing it by finding the decimal value of it. The other way is, one way is the decimal value you can find out, which is not very, very easy to do. Decimal value, and second way of doing it by the method of contradiction. So method of contradictions is something we'll be learning from our 10th standard point of view. So in this method of contradiction, we'll learn that we'll come starting with an assumption that we are going to show. We'll assume that it's going to be a rational number, but we'll make some assumption on that basis. And then we will come to an outcome which is contradicting our assumption. And that is why we come to our conclusion that our assumption was wrong. Hence, it is other way around. So then we say that it is irrational. The contradiction method is slightly confusing sometimes. You do not know the basic fundamental behind the topic. So we'll be learning more of that in thoroughly. But the logic of showing irrational numbers, it's this. So irrational numbers are non-terminating and non-recurring, and we can do it. But in an exam point of view, we should always go with the method of contradiction, right? Thank you.